Alright, I'm Jack. This
I'm
is
Levi.
And we are going to be defining atoms in the periodic table. So,
You can use the periodic table to tell how many protons, neutrons, and electrons are in a certain element.
And the protons and neutrons are found within the nucleus. And then the electrons are found in a electron cloud, which goes around it, around the nucleus.
You can find how many protons or electrons there are by looking at the atomic number, which is its number on the periodic table.
And
the neutrons are within the atomic mass. So you have to minus the amount of protons from the atomic mass to get
the number of protons.
Neutrons.
Sorry.
Close enough.
Wrong thing. And I mean, I'm pretty sure it's very easy to distinguish a positive and a negative charge. I mean, it's literally positive.
Explain it.
Okay.
Explain how you get that.
Basically, so in a +3 atom, it would actually be a negative charge because you're adding. Well, yeah.
Because you're adding 3 electrons, which are negative.
And then in a -3 electron, that would be positive because you're subtracting 3 electrons.
So you're subtracting a negative, which equals a positive. Simple enough.
Yeah.
There are 3 different types of elements on the periodic table: metals,
Non-metals,
and metalloids. Non-metals are mostly gases, and they are bad conductors.
metals are good conductors and are actually the majority of the periodic table.
This is true.
Yeah.
Metalloids have some qualities of both. They're semiconductors, and they can be a solid, a liquid, or a gas at room temperature.
Argon. There are many ways to create energy using radioactive energy, such as fission and fusion. In fusion, you are fusing 2 radioactive materials together.
Mm-hmm.
Yes. And
Fission, you are splitting a nucleus apart into 2 or more smaller nuclei.
And a half-life is the amount of time it takes for a radioactive material to decay by half. So, nuclear energy has both positives and negatives. Most positives are that it's cost-effective once you start it, but it's actually very expensive to create the actual reactor. It's incredibly expensive. It's also very efficient. Not even cost-wise, but the amount of material it takes is a lot less than fossil fuels. However, there's the risk of nuclear meltdowns, which can take out cities. It can also... Is that a paper airplane? It can destroy towns, cities. It's overall very destructive due to human error.
There's also the fact that nuclear energy is non-renewable.
But so are fossil fuels, which leads to my argument that nuclear energy is actually good for us because it actually takes less materials, even though it is non-renewable. But fossil fuels is also non-renewable and takes a lot more materials to create the amount of energy that a small amount of nuclear materials can create. So that's why I think that nuclear energy is a positive. So in covalent and ionic bonds, in a covalent bond, a non-metal and a non-metal are being put together, which creates a covalent bond. In an ionic bond, it is a non-metal and a metal.
Ionic bonds transfer electrons, while covalent shares the electron between the two.
The octet rule is for an atom to be stable that it needs 8 electrons in its outermost shell.
To get these 8 electrons, they create these bonds, either ionic or covalent.
Negative or positive. Elements combine to create an overall charge of 0 because once an element has reached 8 electrons or full stability, it becomes 0 because it doesn't have a charge of anything. It's neutral.
They equal out.
A formula for ionic compounds would be a covalent compound example would be H2O, which is dihydrogen monoxide. A ionic compound example would be NaF, which is sodium fluoride.
These two are examples because H2O is two nonmetals bonded together, while NaF is a metal and a nonmetal bonded together, which makes it an ionic ability.
A binary compound is when two elements are put together. And a binary ionic compound would be a nonmetal and a metal bonding together, which would make it binary ionic. Same goes with covalent, which would be a nonmetal and a nonmetal bonded together, which would make it a binary covalent compound. Write the chemical formula.